Welcome everybody, from wherever you are joining today. My name is John Jarvis, JJ. I'm a technical consultant at Somerford Associates. I work in lots of Hashi products, actually, and I'm certified in Terraform and Vault and Consul. Today, we're going to talk about Vault, and in particular, its integrations with public key infrastructure, PKI. Quick rundown of what we'll cover. We'll start out with a quick intro to the Hashi stack in case you're not familiar with HashiCorp's four main products. Then very quick overview of PKI. More of a refresh, hopefully. It's not a subject that can really be summarized quickly. And then we'll get right into that intersection between PKI and Vault, and how the blessing that it is, believe me, anyone who's worked with PKI for a while. The integrations with Vault are lovely, if I do say so myself. So anyway, we'll do that in terms of two common use cases. So it's going to be fairly short, and then I'll point to some other resources you can look at if you want more information. Of course, you can get in touch with us as well. On that subject, talk a bit about us, Somerford, and who we are and what we aim to be for our clients, and then we'll wrap things up. Okay, so without further ado, the Hashi stack, as it's affectionately known to its fan base. I count myself wrong. Okay, so HashiCorp, it's all about cloud computing. It's specifically helping organizations take advantage of it easily. They don't presuppose what that'll look like. It can be full bore multi-cloud services, all the way to a few early cloud services that an organization wants to seamlessly operate alongside a lot of legacy on-prem stuff. HashiCorp's tooling seen here, and as I say, affectionately known as the Hashi stack, can help organizations right across that spectrum. It's also worth noting at the outset that all four of these products have open source editions, as well as fully featured and officially supported enterprise editions, which we can license if you are interested. Okay, first up, Terraform. Infrastructure as code. This is about the new speed of business, yes, but it's also about all the good things that come with code. So, that consistency, minimizing the risk of humans botching things, as we tend to do, and making sure far and wide in your organization, things are done the same and well every time. An auditor's dream, I like to say. Second, and subject of today's talk, Vault. Secrets management, writ large. Again, it's about consistency, and where there used to be a sprawl of secrets and a hodgepodge of secrets management tooling, now there's a centralized resilient store with the flexibility to cover pretty much every use case, as well as improving on them. And we'll see that today, absolutely. So, for example, in the case of dynamic secrets, where even that worst case scenario, data breach. In that worst case scenario, those secrets, they're only of limited and then diminishing utility. Third, Consul. This is about underpinning all those workloads and applications in a dynamic fashion. For example, this cloud infrastructure that you've codified and built with Terraform changes at pace, and that means your networking needs to keep up. Support tickets for updating firewall rules are out, and automated service discovery is in. Finally, Nomad, an orchestrator like Kubernetes, but focused on simplicity in contrast to the former's complexity. Nomad's happy to work across on-prem and cloud-based workloads too. Which comes back to those organizations who are just starting to dip their toes in the cloud, so to speak. Okay, so as I say, today is about Vault. before we get to that, let's talk about the other star of today's show, PKI, Public Key Infrastructure. So as I say, super quick intro here for those who might need a refresher. I'm making use of the excellent resources from the National Cybersecurity Center for this, by the way. Please do check out that link at the bottom if you're interested in learning more. It's a good place to start. I'm going to use the example of peers attempting to establish a secure connection to explain PKI from a high level. As you can see here, the two entities will share certificates with each other, and they'll be able to verify that the certificates haven't been compromised, that they were issued by a trusted source, haven't been expired or been revoked. That's what I meant to say. And all these things happen through checks with third parties, and therein that's the I bit, the infrastructure bit of PKI. It can't exist without that, basically. Following this, if everything checks out, the two entities have been authenticated to each other, and the secure connection can continue. The protocol can continue from that point on. So that's kind of it in quite a small nutshell, frankly. But hopefully that'll be enough for today. But yeah, the idea is that there has to be a lot of infrastructure in place and available for things to work, and that's where the complexity can come in, really. That and getting all of these things to those entities ahead of time. Another big problem. Okay, so with that then, let us consider Vault's take on PKI, or how Vault can help. So in summary, as I said, PKI provides a way to verify authenticity and guarantee secure communications between applications. In general, setting up your PKI can be a complex and a very manual process. Vault PKI allows users to dynamically generate X509 certificates quickly and on demand. It can also streamline distributing TLS certificates. We'll see how it reduces the overhead around this typically manual, as I've said, process next. All the while also providing an authentication and an authorization mechanism to validate them as well. Okay, so let's dive into the two use cases now. First up, you see on the left there is building a CA, building a certificate authority. And then we'll follow on from that, talk more generally about certificate management. Okay. And these are all covered by, as you can see there, covered by guidance on Hashi's site, and it is really top notch. I definitely recommend checking it out, following on this, and it'll be in the resources that I link to in a moment. Okay, so building a certificate authority. Vault's PKI secrets engine can dynamically generate X509 certificates on demand. This allows services to acquire certificates without going through the usual manual process of generating a private key, and certificate signing request, a CSR, submitting that to a CA, to a certificate authority, and then waiting for the verification and the signing process to complete. We'll see more on that creation process in the next use case. Stepping back from Vault for a moment, a typical challenge for many organizations is that they want to, say, protect their website. However, the traditional PKI process takes so long that they end up creating very, upwards of a year, long-lived certificates, maybe even longer, which creates other security problems, obviously. Enter Vault. It can create X509 certificates, as we talked about, for usage in mutual TLS transport layer security. I should have expanded that earlier, apologies, or other arbitrary PKI encryption. And again, we're going to talk about that in a moment. Those CAs, that infrastructure, that IAM PKI, as we talked about, it can sit entirely within Vault, as shown here. Well, if you can imagine it, it's shown here as all, so both the root CA and an intermediate CA are in Vault in this case. Sorry, lost myself. Yeah. So getting back to our challenge, however, browsers will complain about self-signed certificates in that case, right? As that stands. But again, Vault offers a simple solution. So you can have an intermediate only certificate authority in Vault, and keep the root CA separate, which potentially allows for higher levels of security. That is what, and I'm not going to get into too much detail here, but the idea is that you'd have, that root CA is air gapped basically, and you then create certificate signing requests, CSRs, as I talked about, for the intermediate CA. So you'd have those, and you'd sign those outside of Vault with this root CA, and then import them back into the intermediate CA in Vault. At which point you'd be free to issue leaf certificates from that intermediate CA in Vault for any number of use cases, including your website. And browsers would recognize that, because presumably in your root CA you've paid the coin for those pricey certificates. Yes, so we've hinted at the that certificate creation process quite a bit now, and talked about any number of use cases that Vault as an intermediate CA could solve. That leads nicely into the common use case of certificate management. Okay, so I've decided maybe it would be helpful to have a drawing associated with this process. I've got a lot of the comments for what's going to be playing now on the side. Hopefully this makes sense.
So we've talked a bit about the first use case, setting up a certificate authority, either the root and the intermediate CA or CAs in Vault, or having the root CA air gapped. But for now, let's just say it's ACA, and it's, somehow it exists there. The connection to this use case is around the PKI secrets engine. So what you'll end up doing with the PKI secrets engine is configuring it in the form of a role that will point back to this intermediate CA, which itself is in a chain with the root CA. And it will exist wherever it does for your particular use case. That's kind of the tie-in to Vault. So for this second use case. And it's off the back of this role, a path in Vault, that you'll then be able to issue and renew certificates more generally. And you can have various different roles that could generate different kinds of certificates. And again, they could all go back to, they would all get the authority, they would all get their authenticity from being connected with that CA chain. So in this particular use case, we're talking about how do we get those certificates to your applications, right? We won't go into too much detail about where those applications sit or what they are. Just we want to have the idea that they need a certificate, they need to be able to renew certificates. We want to centrally manage those, and that's where Vault comes in. So the next piece we need to consider then is that we're not doing this manually, right? We're automating it. So in the moment, how does App A prove that it's deserving of that it's allowed to have certificates, or it's allowed to renew certificates. Well, so this is another area where Vault comes in, not with secrets engines this time, but with an auth method. And so it's an auth in particular. Not surprisingly, it's one of the more popular automated auth methods, app role. So won't get into too much detail about app role because it's a whole subject in itself, but largely you can think of the role ID as a username and the secret ID as a password within app role. There's a few different ways to configure this. The simplest one is to issue both of those at the time of configuration and set up your application such that it knows both of those. Some risk associated with that. We've certainly seen that with our clients. They've done that for pipelines, and it's absolutely fine. But in keeping with the idea that the air-gapped root CA might be something that you're considering if you have more stringent security requirements. Similarly, there are you have the ability through wrap tokens. Again, won't get into too much detail on that. To issue a secret ID just in time, I guess you could say. Basically, the app won't, at the time of configuration, won't know its secret ID, but can securely request it, limiting the attack surface even more, I guess is the point there. Either way, and so that's why the dotted line is there, depending on how, your use case. So either way, jump ahead to the point where App A now knows everything it needs to know to authenticate to Vault, does so, hits app role in Vault, and is issued a token that has policies associated with it. One of those policies is going to be associated with certificates, requesting certificates, renewing certificates, that kind of thing. And again, that's all down to permissions on paths in Vault. So for example, to do a read of a renew path, could issue renewal. A read of another path could create an entirely new certificate. The idea is you can lock this down as much as you need to, and if we're following this example, the policies for App A mean that it's specifically going to be able to generate certificates for its own use. And you can extend that example out. Again, I think I said this before, multiple roles for various different types of certificates, etc. Lost my train of thought there, sorry. But to sum up, so at this point, we've issued a certificate in our example, and there's different ways that can be consumed. But one of the ways is for Vault Agent to write that to a file system or whatnot that App A can then consume in its usual manner, and not even realize really that it was ever interacting with Vault. In the case of Vault Agent doing all of that for it, it just sees a certificate on the file system end and proceeds as it would normally. There are a few other ways that you could consume that information from Vault. The point is that you want it to be able to be the central point for the issuing of certificates, for the revocation of certificates, for the renewal of certificates. And this is how you would set that up. Again, all those different paths associated with any particular secrets engine. So I hope that's been somewhat clear. If not, please do feel free to reach out, sorry. I'd also recommend checking out developer.hashicorp.com because they have lots of tutorials, including the tutorials that I'm a bit randomly following here on certificate management. Thanks very much.
Okay, so yeah, that's in a nutshell. The second use case. I included some text to the side that was kind of, you could have been reading alongside that in the hopes of condensing it down. Again, if it wasn't clear, please do reach out, because the point that was hopefully conveyed is that it is much, oops, no, that's not what I wanted to do. That's better. Much simpler to it's simpler certainly to set up, and it's much simpler to operate than a traditional PKI. And I do know from where I speak, having worked with PKI many multiple decades ago now for my sins. Okay, so just to kind of finish up here, I just want to have a quick slide on. We talked earlier in the HashiStack slide about the enterprise options. I just wanted to bring that up now in the context of Vault quickly. You know, when we typically see clients considering the migration, it's particularly relevant when we talk about PKI as well. You know, as we've seen, Vault simplifies the barrier to entry when it comes to this complex technology. But as we often say, Vault is quickly finds itself in the business critical path, or more colloquially, you know, Vault often finds itself a victim of its own success. And so if your plans do include a large user base, or maybe some compliance requirements or things like that, might be time to, and you know, that's just a few of the considerations, might be time to consider thinking about Vault Enterprise. Okay, so promised some extra resources here a few times now. Those tutorials that I talked about. So that's the first one there, the first use case tutorial there. And if you wanted to have some more information about the, you know, having the root CA outside of Vault, you know, that more stringent security, or, you know, to deal with a more significant threat model, that second tutorial builds on it, builds on the first one. There's also, I mean, it's not necessarily just HashiCorp. I like the Sam Tekanade, his stuff. That video is a little bit old, but it's still really good. It runs through a demo of basically building it all up, much like in the HashiCorp demos, building it all up with Terraform as well, which is kind of neat. And then there's been a revamped blog post. It is a blog post, but it's really like step by step on the certificate management stuff that we've been talking about. Really runs you through the whole thing, so you can set it up yourself. And then there's also, I mentioned that little that optional bit of config you can have with app role, where you might not necessarily want to have the secret ID generated at configuration time and persisting somewhere. Again, absolutely valid use case, but if you just want to look at the differences available there, that's definitely a good place to start that particular blog post. So just to finish up now, one last slide about us, Somerford. Okay, so we're experienced in large-scale deployments. Our clients come from all sectors of industry and government. We tend to focus. You see the partners there on the right. We tend to focus on the Gartner Magic Quadrant leaders. You know, kind of best in breed. We invest in our staff. They're well trained and certified in all the technologies we present or represent even. Our technical team provides pre-sales, implementation, and post-sales support. Our approach is to understand the business problem and to recommend the right solution. So whether you're looking for, you know, a sounding board to understand your problem space, to tune a solution that's already in place, or anything in between, just consider talking to us. The idea is we'd like to be a trusted advisor first. We're sufficiently removed from said partners that we can, we like to think that we can provide an objective point of view. really, that kind of just leaves me to thank you very much for your time and attention. And again, reach out if you have any questions whatsoever. Thanks very much.